Hello everyone. In this tutorial I'm going to go over how we can multiply polynomials together using algebra tiles to help us. Okay, so the first multiplication problem we are going to look at is the quantity of x plus 3 times the quantity of x plus 2. So to help us solve these problems we can use algebra tiles. And algebra tiles I have put off to the side here. These are the ones that we use. We have an x squared and a negative x squared. We have an x that is the same height as x squared because x squared would be x times x. So just one side would be x and then a negative x. And then we have a 1 and negative 1, which this x tile, the height is x and the width is 1. It's the same width as the 1 tile. So these are the tiles that we use. And what we can do is use this little chart here to fill in the problem and then fill in with tiles to help us see what this would equal. So what we can do is we're going to put each one of these parentheses, each polynomial, one on each side of the chart. So the first one, x plus 3, we have a positive x and a positive 3. And then along the top we have a positive x and a positive 2. So what I'm going to do is I'm going to find the area of this space here. So remember when we find area, it's base times height. So I'm going to multiply these two sides together. And to do this, I can split it up into different chunks. So I'm going to multiply each part of the rectangle at a time, so one part at a time. So the first thing I'm going to do is x times x. This is the first part of the rectangle here that I'm going to multiply. X times x, I know that this equals x squared. So this portion of the rectangle here is going to be x squared. That is the area of this part here. Then I'm going to multiply the next part. This section here, the height is x and the base is positive 2. So I have x times positive 2 is positive 2x's. I have 2 x's. So I'm going to take 2 of these and put them here. Okay, so I went ahead and put my 2 x's on here. Since we have positive 2 times x, we have 2 positive x's. Next, let's find the area of this section. The height is positive 3 and the base is x. So this is going to be positive 3 times x. So in other words, we have 3 x's. So I'm going to take 3 of these and fill them in right here. Okay, so there we have now 3 positive x's. Since it is positive 3 times x, that means 3 positive x's. Then the last part of the rectangle to fill in is right here. So the area of this, the height is positive 3 and the base is positive 2. So I'm going to do positive 3 times positive 2 to get positive 6. So I'm going to be putting 6 of these positive ones in this space now then. Okay, so there are my 6 positive ones for the 3 times 2 is positive 6. So now we're going to see what the total area is, or what this would be after we multiply all of this times all of this. So we're multiplying the complete parentheses together, or the complete this side times the complete this side. So we have 1x squared, so I have an x squared. I have 1, 2, 3, 4, 5 positive x's, so I have 2 positive x's. And 3 positive x's. And then I have 1, 2, 3, 4, 5, 6 positive 1's, so a positive 6. Then I can combine a little bit more here. I have 2 terms that have just an x, they are in common, so I can combine them together. In total, we have 1, 2, 3, 4, 5 positive x's. Positive 2 plus positive 3 makes 5 positive x's, and then the rest stays the same. And this would be the answer to the multiplication of those two polynomials. So here's another problem that we can try to solve. So we're multiplying the two polynomials, x plus 4 times the quantity of x minus 2. So to help us solve this, I'm going to use my area model again, and I will make these two lines. Then I'm going to fill in, first we have x, and then a plus 4, a positive 4, and then an x, and then minus 2, a negative 2. So notice how I keep the sign with the number, because the sign that comes before the number is the sign of that number. So this is a positive 4, and this is a negative 2, so I kept it together like that. So then we just multiply each part of the rectangle to get our total area. So the first part, x times x, that makes x squared. Then we have x times negative 2. So this means I have two negative x's. X times negative 2 is negative 2x. So I'm going to take two of these negative x's and put them here. So there we have our two negative x's. Now let's take a look at this area, this part of the rectangle. Positive 4 times x. That means we have positive 4 x's, 4 positive x's. So I'm going to take 4 of these positive x's and fill them in here. So there I have my 4 positive x's. And lastly, the area of this section here. We have positive 4 times negative 2. Positive 4 times negative 2. Positive times negative I know is negative. 4 times 2 is 8. So this area would be negative 8. So I'm going to take 8 of these negative ones and fill them in here. Alright, so there I have my 8 negative ones. So let's go ahead and see what this area is all together. So this first part I have 1x squared, 1 positive x squared, so I have a positive 1x squared. The next part here I have 2 negative x's, so this is going to be a negative 2x. Next step I have 4 positive x's, so I will have a positive 4x. And then lastly we have 8 negative 1's, so I have a negative 8. I'm noticing we have two terms with just x's here with no exponent, so I can combine those. So I have, in my area model here, I have 2 negative x's and 4 positive x's. Negative and positive cancel, so I can go ahead and cancel pairs of tiles here, that of a positive and a negative. So what I mean by that is this negative x tile cancels with the positive x tile. A negative x tile cancels with the positive x tile. And then we are left with 2 positive x tiles. So we have a positive 2x. And everything else stays the same, nothing else canceled. And this is the most simplified answer of the multiplication of polynomials. Which makes sense because if I have negative 2 plus positive 4, that equals positive 2. So that's where this picture comes in. It gets you the same thing. Okay, let's take a look at one more example now of multiplication of polynomials using algebra tiles. So the first step is I'm going to make my chart. And then I'm going to fill in with each polynomial. So the first one we have is 3x plus 1. So this 3x here tells me I have 3 x's. So I'm going to fill in with x, 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 and then we have a plus 1. And then for the top one, for our second polynomial, we have 2x plus 1. So we have 2 x's. And then a positive 1. So now I'm going to go ahead and do my multiplication to fill in the area of the entire space here. So first we have this section, x times x. That gets us x squared. Then I will do the same thing with this next section. X times x, again, is x squared. Okay, now for the next section, we have x times positive 1, meaning we have 1 positive x So I'm going to fill in that space with a positive 1x. All right, let's move down to here. Now we have x times x again. The height is x, the base is x. So again, this is an x squared. Okay, moving on to here. Again, x times x again is x squared. So I'm going to fill in with the x squared. Okay, next section, we have x times 1. So that would get us a positive 1x. Next section, x times x again is x squared. Okay, next section, x times x again is x squared. And then this next section here, we have x times 1, so that gets us a positive 1x. I'm going to move this one out of the way. There we go. All right, then our next section down here, moving along, we have 1 times x, and so that gets us again a positive x. And then down here, 1 times x, again, another positive x. And then lastly, this section here, we have positive 1 times positive 1, positive 1 times positive 1 equals positive 1. All right, so let's see what the area is of this entire space here. We have 1, 2, 3, 4, 5, 6 positive x squareds. So nothing cancels, they're all positives. So I have a positive 6x squared. I have 1, 2, 3, 4, 5 positive x's. So a positive 5x. And then we have one lonely little positive 1 down there. So lastly, positive 1. So 6x squared plus 5x plus 1 is the answer to the multiplication of these two polynomials. I really like the algebra tiles with the multiplication of polynomials in the area model because I think it really does a nice job of being able to see exactly every single part of the multiplication, so you can really easily see in front of you the entire answer to the multiplication of the two polynomials. However, as your polynomials get bigger, we've just multiplied binomials, and as we went along, they got bigger and more complex. But if you multiply polynomials that are even bigger, like trinomials and even more, the area models would get to be a bit much with all those little tiles and everything. So I'm going to show you another method to multiply polynomials where you don't have to move around all the little pieces. So I'm going to first show you this with another binomial just so you can see a similar problem to what we did before, but with just a new way. So we have the quantity of x plus 3 times the quantity of x plus 4. So we're multiplying the two polynomials together. So every piece of this first parenthesis needs to be multiplied by every piece of the second parenthesis. Using the distributive property is what we're doing. So we're multiplying this x times the x and the minus 4 in the second parentheses, and we're multiplying this positive 3 times x and the negative 4 in the second parentheses. So everything's getting multiplied in the two parentheses. A way that we can make sure that we do this is by making a box. So in my first set of parentheses, I have two terms. So in my box, I'm going to have two spaces going up and down. In my second set of parentheses, I also have two terms, so I'm going to have two spaces from left to right as well. And then I'll fill in similar to how I did with my chart before. Positive x and a positive 3, then a positive x and a negative 4. Then we can just multiply each one of these pieces. So we have x times x. Without even using the tiles, I know that this is x squared. We have x times negative 4. Without even having to fill in, I could know what this is. I know that I have 4 negative x's, so I would use the 4 negative x tiles for a total of negative 4x. Here we have positive 3 times x. So again, here I would use the 3 positive x's. I have 3 positive x's there, or I can just put a positive 3x. And then lastly, we have positive 3 times negative 4. I know that positive 3 times negative 4 is negative 12, since positive times negative is negative. Then we take each one of these and we write it out all as one complete polynomial. So x squared, a positive x squared, minus 4x, plus 3x, minus 12. Then we'll see if we can combine anything. We have two terms with just the single x, so we can combine them. We have 4 negative x's and 3 positive x's. If you aren't totally sure on how to combine them, you can make little mini tiles. 4 negative x's and 3 positive x's. Positive and negative cancel, and we're left with 1 negative x, so this is a negative 1x, and then everything else stays the same. So this is the answer to that multiplication. Okay, let's take a look at another one now. So again, I have two terms in each set of parentheses. So in my box, in both directions, I will have 2 spaces. Then we'll fill in 2x and a positive 4, 3x and a positive 1. Then we can multiply these. So the first box, we have 2x times 3x. So in this case, I can multiply the numbers separately and the x's separately. So I have a 2 times 3, that's 6. X times x, that is x squared, so 6x squared. Next, we have 2x times 1, so that means I have one group of 2x, so I just have a positive 2x. Then down here, we have a positive 4 times a 3x. So I'll multiply the numbers. Positive 4 times positive 3 is 12. Positive 12. And then there's no x's to combine besides just this 1. So I just have the 1x to add in there. So it's a total of positive 12 x's. If I were to have my tiles, this would tell me I have 4 groups of 3x's, so 3x, 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 for a total of 12 x's. So that's where this 12x comes from. And then lastly, positive 4 times positive 1 gets us positive 4. So then we'll write it all out. Then combine the like terms. Positive 2x plus positive 12x. Nothing cancels, they're both just positive. So in total, we have 14 x's plus 4. So the times when this box method really comes in handy is if we have many terms that we're multiplying in each set of parentheses. Because really what we're doing here is we're doing x squared times both terms inside the other parentheses, 2x times both terms inside the other parentheses, and 3 times both terms inside the parentheses. So to help us make sure that we're multiplying each of these by both of these in the other parentheses, we can use this box. And this time, in the box, we have, in our first set of parentheses, we have 3 terms. So I should split this up into 3. And then in the second set of parentheses, there are 2 terms. So I will split this way into 2 pieces and then fill in. And then we'll multiply each section. So the first part, x squared times 4x. So first I'll work with a number, and there's just one whole number, just a 4, so it stays a 4. And then I'll multiply the x's. I have x squared times x. This is when it really comes in handy to know your exponent rules. If we have x squared times x, this x is really like an x to the power of 1. Our exponent tells us how many total x's we're multiplying all together. So all together, I'm multiplying 2 x's here. This is x times x. And here I'm multiplying 1x. So all together, I am multiplying 3 x's. So my exponent should be a 3 because I'm multiplying x times x times x, or in other words, 3 x's. The next section of the box, we have x squared times positive 5. So this would be, if I were to have the algebra tiles here, I would have 5 sets of x squareds. But I could just go ahead and write it as this positive 5x squared. I have 5 x squareds. Next, we have positive 2x times 4x. So first we'll start off with the numbers. Positive 2 times positive 4, that would get us 8. Then our x's, we have x times x, x times x, and x times x, that gets us x squared. Then our next section of the box, 2x times 5. This would tell us we have 5 sets of 2x for a total of 10 x's, positive 10x. This section of the box, we have positive 3 times 4x. So we have 3 groups of 4x's for a total of 12 positive x's. And then the last section of the box, positive 3 times positive 5 is positive 15. So let's go ahead and write this all out. Notice how everything is positive, so in this case, everything is addition. All right, let's see what we can combine. So we have an x to the power of 3. No others have x to the power of 3, so this one I will not combine with anything. Here we have an x squared, and we have another x squared, so we can combine those. We have 5x squareds and 8x squareds for a total of 13x squareds. If I had my algebra tiles, I would have 13 of those x squared boxes. Next up, we have an x and an x term that we can combine. We have 10 positive x's and 12 positive x's. So in total, we have 22 positive x's. And then lastly, the 15 is the only whole number with no x at all or other variable, so we'll just leave it like that. And this is the final answer to the multiplication problem.